Hi everyone. In today's lesson we are looking at Chapter 6, Section 2, Properties of Parallelograms. Our objective is to use some properties of parallelograms and relate it to real-life situations. Our standards are GCO 11. What is a parallelogram? A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So in the picture over here, you can notice that line segment AB over here is parallel to line segment CD, and line segment BC is parallel to line segment DA. Theorem 6.2. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So from this picture we can say that line segment PQ is congruent to line segment RS, and line segment SP is congruent to line segment QR. Theorem 6.3. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So in this picture over here, angle P, its opposite angle is angle R, so angle P and angle R are congruent. And angle Q is opposite to angle S, so angle Q and angle S are congruent. Theorem 6.4. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Consecutive means to follow continuously. So in this case over here, we can see that angle P and angle Q are consecutive angles, and angle P plus angle Q is equal to 180 degrees. Angle Q and angle R are consecutive angles, and angle Q plus angle R is 180 degrees. Angle R and angle S are consecutive, and they add up to 180 degrees. And angle S and angle P are consecutive, and they add up to 180 degrees. Theorem 6.5. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Bisect means to cut in half, so we can say that line segment QM is congruent to line segment SM. PM is congruent to RM. Let's take a look at our first example. In our first example, we are given that STUV is a parallelogram. We are to find the unknown lengths. The first length we need to find is TU. T2U is right over here, and we notice that this is parallel to this length over here, and we know from Theorem 6.2 that if we have a parallelogram, then its opposite sides are congruent. So TU is equal to SV, and since SV is 12, then we're going to substitute 12 for SV, and we get that TU is also 12. Next one, we're looking for WT. WT looks like it is a diagonal inside the parallelogram, and we know from Theorem 6.5 that diagonals inside a parallelogram bisect each other. So WT is equal to WV, and since WV is 14, we can substitute 14 for WV, and WT is 14. Example number 2, we're using properties of parallelograms. We're given that JKLM is a parallelogram, and we are asked to find the measure of angle L. Well, angle L is right over here, and we notice that we are given its consecutive angle measure, which is angle M, and that is 135 degrees. We know in a parallelogram, consecutive angles are supplementary, so the measure of angle L plus the measure of angle M is equal to 180 degrees. We can substitute 135 for the measure of angle M, and we can subtract 135 from each side to get that the measure of angle L is 45 degrees. Example number 3, using algebra with parallelograms. We are given ABCD as a parallelogram. We are asked to find the value of x. We can see that angle C and angle A are opposite angles, and we know from Theorem 6.3 that opposite angles in a parallelogram are congruent. So we can say that the measure of angle C is equal to the measure of angle A. Then we just substitute the variable expressions for angle C and angle A. Add 34 to each side to get 9x plus 36 is equal to 12x. Subtract 9x from each side to get 36 is equal to 3x. And then divide each side by 3 to get that x is equal to 12. All right, checkpoint problems number 1, 2, 3, and 4 are yours. In checkpoint problems number 1 and 2, we are finding the measure or value in a parallelogram DEFG, and we have to explain our reasoning. So checkpoint problem number 1 asks you to find the measure of angle D, and checkpoint problem number 2 asks you to find EH. Checkpoint problem number 3, using the same parallelogram DEFG, we are asked to find the value of y in the parallelogram. Checkpoint problem number 4, using the same parallelogram DEFG, we are asked to find the value of x in the parallelogram. Using parallelograms in real life. Gemstones. A gemstone is cut so that one of its facets has 4 sides. The measure of the consecutive angles in the facets are 45 degrees, 135 degrees, 135 degrees, and 45 degrees. Is the facet a parallelogram? Explain. Let's start by drawing this facet. So we know it's a 4-sided figure, which means it's a quadrilateral. And we're given that the consecutive angle measures. So consecutive means following right after the other. So one of it is 45. The other one is 135. Right after that is 135. And then this one is 45 degrees. Well, the facet is not a parallelogram. Here are the 2 reasons why. First, the opposite angles are not congruent. So if you look at the opposite angles, this angle is 45 and this is 135. They are not congruent. Same thing over here. This is 45 and this is 135. The second reason why is the sum of the measures of the consecutive angles are 180. So if you add up 45 plus 135, you get 180. And then if you add up 135 plus 135, you get 270. And then going 135 plus 45, you get another 180. And then 45 plus 45, you get 90. But we know from Theorem 6.4 that each one of these consecutive angles has to add up to 180 degrees, and that's not what we're getting. So if the facets were a parallelogram, then all pairs of consecutive angles would be supplementary. All right, that's it from me. I'll see you all soon.